All right. Welcome, everybody. As I said on my Wednesday talk, I really need to get a better intro. If you have any ideas of a cool slogan of something very IOTA specific that I can use as my intro, please let me know. We are here to entertain, right? We have a very exciting week behind us where first of all, we brought more clarity on the Chrysalis timeline, which is absolutely amazing that we have that clearly defined now. And we also had some really exciting stuff with Stronghold today, which I'll talk about. And then we have Luigi on the show, who will talk about courticide, mana, and rate control. Since it is really the most important component of courticide next to FPC, the consensus, I think we have a very exciting discussion to really elaborate further why it's so unique and why it is required within courticide. Without further ado, I think we should jump into it. As all of you know, right, last time we spoke about uncertainty. And uncertainty in this crypto space basically reaches new level because you have all of these different unknown variables that you have to take into account when you go on this journey to build out a new distributed ledger, or even when you go out on a journey to build a decentralized application on top of a protocol. And the role of us at the IOTA Foundation is to remove as much uncertainty and as many unknown variables as possible. Now, when it comes to Chrysalis, right, let's repeat this once again. Chrysalis is writing IOTA from scratch. And the main reason why we completely rewrote IOTA from scratch is to be production ready, right? Is to have a very clear path to go from the current IOTA towards a new version of IOTA that is going to be adopted by corporates and that is going to be adopted by startups and governments and all people that really want to benefit from feeless micropayments and from secure data transfers, right? And the ultimate objective of IOTA is to be production ready. Now, with Chrysalis, what we're doing is we are introducing standard cryptography. We are optimizing some of the algorithms, especially when it comes to the confirmation of transactions. And we're also introducing other exciting stuff like UTXO, because UTXO, unspent transaction outputs, are really a very exciting concept first introduced by Bitcoin, which makes the ledger more maintainable, makes it also more usable, because then we can do stuff like digital assets. And all of this is with this main objective in mind, that we are on this clear path towards production readiness. Now, after Chrysalis, the only last remaining thing is to remove the coordinator, right? And with that, we are one of the most decentralized protocols out there. And we're going to talk with Luigi about that as well, what it actually means to be a leaderless consensus protocol. But that is the main objective, to be a production-ready, decentralized, secure, and feeless protocol. And that's why all of you are so excited about IOTA as well, because we are on this journey and we have removed all of these unknowns and all of these negative influences or negative components of the protocol to really go towards production readiness. Now, when it comes to Chrysalis, I think we started working on it probably a year ago. So the first version of Chrysalis went live in August 2020. And right now we are in March 2021. So a lot of effort, a lot of time went into it, because it's not just the node software, it's everything. We had to rewrite the node software in Rust, in Go. We had to introduce a new library standard. We had to introduce new modules and libraries for the wallet. And we had to introduce a new wallet. And all of that is right in front of us right now. And that's what makes it so exciting. So what we are doing right now, so all of these components are largely finished. Now we are in this final phase where we are preparing for the actual migration and for the actual mainnet upgrade. And what we published earlier this week are the exact dates. So as we stand right now, the final dates for Chrysalis will be the 21st of April for the migration. That means on the 21st, you can officially start migrating your tokens to Chrysalis. And then on the 28th of April, we are officially going to launch the Chrysalis network. And that is really the biggest milestone ever. There was a missed opportunity to benefit from the 420 marketing campaign, right? We just realized that afterwards that we should have probably started with 20th of April. But you live and learn, right? And would have been funny, but yeah. So these are the definite dates. 21st of April for the migration, and 28th of April for the mainnet upgrade. That means that after the 28th, the current IOTA version, the current protocol, the current network will only support the migration to the Chrysalis network, and the Chrysalis network will be will be live, right? Everybody can start utilizing it, can start trading on it, and can start building on it. So that's incredibly exciting. On Monday, or like early next week, probably on Monday, we're going to publish Firefly, so that all of you can also enjoy and participate in Chrysalis, enjoy reusable addresses and all of the amazing stuff that comes with it. So far, I think only a smaller portion of the community was able to participate, right? Those that know how to set up nodes. But with the release of Firefly early next week, we are definitely opening the floodgates, so to say, so that all of you can join, and we're going to have some fun with that. For all of the developers out there, I can already now encourage you to look at our documentation, because that is really the entry gate to this new version of IOTA. So please look at the documentation and really look at the libraries that we wrote to really make the integration efforts of IOTA even simpler and also extend the features with it. One thing to mention, our objective was to release Chrysalis end of Q1. That means end of March. While it was our objective and it was our internal timeline, things don't always go as planned. And I think the biggest unknown in our planning was the exchanges, because we largely assumed that they would be ready to switch as soon as we told them. But the biggest difficulty that we faced is we could have either tried to rush everything through to meet the timeline, but the challenge then would have been which exchanges would actually support Chrysalis. And some of as we discussed more with some of the largest exchanges, including Binance, it became kind of apparent that they themselves have real issues in terms of scheduling stuff like that, because they have to go through a vetting process. And resources for them are also scarce. And some of the largest exchanges told us like they can only really start early April with the integration of Chrysalis. So we ultimately made this decision to go with April 21st for the official launch date, and right now really support the exchanges so that when we launch Chrysalis, that at least 3 to 4 exchanges are officially supporting us, and I think we are on a good track with that. And the new launch date makes it possible for us to refine things further, to enable ledger support for Firefly, and to really harden everything and even optimize as the Hornet team has been doing. So I think even though we didn't meet the objective of Q1, it's still a very exciting day, because we now have a definite time. We know exactly when we feel comfortable with doing the upgrade, because ultimately this isn't just about deploying some new node software. It is about migrating billions of dollars from the current IOTA network to the new IOTA network. So we have to be absolutely certain and absolutely careful. And so far we've had I think 3 audit firms auditing the code. We did a lot of internal reviews. We did something called Rust Week, where all of our Rust engineers just look at specific software repositories to figure out what can be improved and if there's any bugs. So the internal review process has been ongoing for a long time as well. And we're really now at the stage where all of you can also start trying out Firefly and participate. And overall, I think we are a month away, right? And that gives us 1 month to draw more awareness to what this new future of IOTA looks like, and also start to excite all of you more what IOTA with Chrysalis really means. Because as I already mentioned, I think very few people actually transacted on the network yet, or have reused addresses, right? Something that has been a strict no-go so far. And so I think it's very exciting that we can start doing that. So maybe we as a community should also think about what we can do, like fun activities. Like I remember that for the Bitcoin Lightning Network, they had this like carrying the torch or something on Twitter, where you could ping somebody to give them the Bitcoin Lightning torch. Maybe we can think of similar ideas. But yeah, with that in mind, early next week, Firefly, 21st of April, migration start, 28th of April, official upgrade. We're not going to do a countdown, right? All of us have bad feelings about countdowns. But I think we should really look forward to that date and get prepared for it. Another awesome, this looks absolutely beautiful, by the way. I would use this as a background on my computer. Attackathon. Now, as I already mentioned, right? We have done multiple audits on our software. We have done a lot of internal reviews of our software. Now, the next phase of this would be to do a big bug bounty, right? Where you have prices of $30,000, $40,000, $50,000 for finding serious bugs. But because we are very comfortable in where we stand right now with our software, and because we really wanted to engage the community more and also reward them for their participation, we came up with this Attackathon. Basically, it's sort of like incentives or rewards for finding certain bugs in the software components of Chrysalis, and obviously like submitting them and then winning rewards for that. Initially, when we released this, I think there was a misalignment between what we had intended with it in terms of the communication and how it was received. And I think this is definitely a fault on our side if it was not received in our intended way, because many people thought that this was a bug bounty, and obviously having prices of 200, I think it was before 250 euros for priority one makes no sense, right? We know that. Like we first of all, we're not greedy, and second of all, it was never intended as a bug bounty. But this was our fault in terms of the way that it was communicated, because the challenges, the overall structure looks very much like a bug bounty program, but it's really intended as sort of fun activity for the community to get all of you more engaged and to also really use this time that we have right now, right? We have 4 weeks to read up on IOTA, read up on Chrysalis, and just to start participating in the testnet together with us. So make sure to take a look at the Attackathon blog post. Make sure to go on Discord if you're not there yet, discord.iota.org, in order to participate here. And we have some rewards that we are going to announce, some other like more funky rewards that we're going to announce as well, just to keep the community more engaged and more rewarded for their work. But yeah, make sure to join and to participate in it. And if you find anything, just report it. I think you have to report it on GitHub or via email to us. In addition to that, something else that we have done as a sort of interesting exercise to engage the community, but also to engage the security community, is to do a capture the flag with Stronghold. So today we had the Stronghold beta release, and that's very exciting. For those of you that don't know, Stronghold is one of the most important components of the Firefly wallet, and Stronghold, as the name already suggests, is there to keep your keys and your data safe, so that even if there is a malicious third-party integration that was conveniently hacked, your seeds will not be stolen, right? Your seeds, your keys remain with you. And that's exactly the main intention of Stronghold, to be the secure enclave within the Firefly wallet. There are two very exciting videos that you guys should look at if you want to learn more about Stronghold. There's the open source series that Daniel did. I think we'll link it in the description afterwards. And there's also an IOTA talk that I did with Daniel speaking about Stronghold. The most simple explanation that I can give you is this image here. And I think it's quite beautifully made, right? If you request something from the chef and you don't, or if you request something from Stronghold and you don't have the right identity or the right credentials, Stronghold is not going to give you the key. It's not going to give you what you want. And so you really need to, it's really this interesting security component where Firefly requests something from Stronghold and vice versa. So you can think about it like a password manager that we integrated into the Firefly wallet. As I mentioned, as part of Stronghold, we are doing a Capture the Flag challenge. Basically, what you can do here is you can try and crack the Stronghold container. And if you crack it, there's a seed with $5,000 worth of IOTA tokens on it. And if you crack it, right, you can submit it to us on Discord, and you can also keep the seed. We are obviously quite comfortable here. But I think this is a very interesting and exciting challenge. So make sure to join our Discord again. I think there's a Stronghold channel where you can join. But also, I can really encourage all of you to read up on what Stronghold is and what it enables. I think with the release of Firefly next week, we're also going to publish a sort of architecture document that shows what Firefly is, that shows what Stronghold is, and that shows what Wallet RS is, because those three separate components make up the new wallet. And we obviously learned a lot from the Trinity days. I really think that the new wallet is one of the most secure and one of the most convenient to utilize. And Stronghold is one of the most important enablers of the Firefly wallet. One very exciting thing, right? Keep in mind that with Firefly and with Chrysalis, you're not just hodling your tokens, you're strongholding them. And that's another exciting reason. Is it just like that's a reason alone to just use Firefly, because of the exciting memes that we can all share about strongholding. And when it comes to Stronghold, it will go further than that, right? I think with Firefly as well, the vision is not just to be a wallet. The vision is really to be this new gateway to these decentralized economies. So you can also hold your other digital assets with Stronghold and Firefly, or you can also hold your digital identity with it. And I really think that this will be a very exciting path towards a more secure and also towards a more decentralized future, where you can comfortably hold your keys and not worry about them. So make sure to check that out and check out the hackathon, because this is a fun challenge. And with that, let's get Luigi onto the show.
Hi, Dom.
Luigi, can you hear me?
Yes, perfectly.
Wait,
Hi, thanks for inviting me. Can you hear me well?
Yeah, I can hear you.
Right.
I just almost have to put on the headphones because they're kind of annoying to wave around, you know. So,
yes.
So
very exciting times, actually. This Chrysalis update, the Stronghold. I mean, it's not just the old times when we are just making hypotheses. Here we are really making a change, really releasing the serious stuff. The Chrysalis update really makes me very excited. It's a big thing there.
Yeah, totally right. And as you said, it's all sort of coming together. And I always think about IOTA as this mosaic where there's like one important puzzle piece, and this year we are really stitching it all together, and it's really, really nice. So you've been part of IOTA since the very early days. So tell us a little bit about yourself. I think the community is really excited to hear that.
Yes, now it's almost 3 years So I joined in 2018. So, and it has been a very emotional path in these 3 years. We started from scratch. So we started from the Tango white paper, and now we're really building everything on top of that. And so that's why this year I really feel that we are delivering. We have a lot of things to deliver. You see now the Firefly, Stronghold, the Chrysalis, just to mention 1 month, and without mentioning the Ghost Shimmer testnet that gets updated like every couple of weeks. So it's you see that so we have this research team that is growing together since 2-3 years. So as you said, I'm one of the oldest there, and we're really putting the pieces together to deliver this core design project and all the other functionality of IOTA. So yes, I joined in 2018. I'm Italian from South Italy, Galatina, as you can see from these nice pictures.
Beautiful beaches.
From Salento. Maybe some of you know it's becoming a very touristic place with beaches, pasta, obviously, art, warm weather, and summer especially. So I invite you to come if COVID allows, obviously. I studied in Italy. I did my master. Actually, I did a double degree between Italy and France. And then I pursued my studies in France, specifically at Eurocom in French Riviera. My background mostly, goes into optimization, network modeling, and everything that is basically related to performance, optimization, and modeling. So I have to admit, when I joined IOTA in 2018, I was not the most expert person on the blockchain world, but I had one feeling. It looked to me, for a researcher, it's like a playground because you have so many interesting problems. And yes, Bitcoin was providing us, a proposal, but it's not a solution. Because it's really not efficient, it's really not really useful for actual use cases. So, having this background in networking, where you always study problems that have been, studied for 30 years right now, because you study how to optimize the internet, reduce the latency, improve the throughput. These are well-known problems. So you're gonna optimize it, the 0.1%. Here, the margin of improvement that you can have and impact you can make is very huge. And basically, you can reuse what you have learned from the past experience and apply for these new use cases that obviously it's a bit more complex, but still you don't have to reinvent the wheel from scratch. And my background was actually really useful to get into this world and play and try to contribute in IOTA.
No, I think that's actually a perfect way to phrase it, and I've never thought about it like that actually, right? You have this very exciting background of telcos, and telcos are solving a similar problem than we do, right? How to get data from A to B, how to build up these secure networks, how to provide connectivity. And as you said, it's a very established field. So the optimizations that you're looking at there are marginal, right? It's not some huge magnitude of difference that you can also do. And then upgrading the infrastructure itself is another big challenge, because it's like physical wires that you have to rewire and relay. And so it's kind of fascinating that what we are doing with distributed ledgers is we can apply old principles, say the same principles from the existing infrastructure that we have to distributed ledgers, to this digital infrastructure, and then optimize it and enable it, right? And so your background is really perfect for that.
Yes, and one of the things that was lacking this blockchain world was people started to do things, but without really focusing that much on thinking of what it is possible to do and what is the best way to do things.
Right.
And this is actually what research does. So I think IOTA took a different approach. We maybe went a little bit slower at the beginning, trying to make something a little bit more thought. So we not just solve with the proof of work and then, okay, whatever happens, we have a centralization and fee and stuff. No, we're trying to do something more. We're trying to give a product that can be useful, it can be, the most efficient. Then obviously you can always optimize and later, but we had taken our time, this 1-2 years of trying to brainstorm with several meetings and stuff, and now we converge to some solution. And this was an exercise that was not trivial to do, because people most likely they want to get things done and deployed and implemented. We took our time, and our role in the research team was actually to do our homework and to try to deliver something that is more than just a proof of work based blockchain.
Right. Exactly. And I mean, like, what do you think was the biggest challenge of Coordicite? Is it really enabling a protocol with no fees? Because if maybe let me rephrase it. How would you build a consensus protocol like IOTA, right? The distributed ledger. Like, what are the different components? It's consensus, it's networking, and what else?
Yes. So I believe we have well, definitely these two are the biggest component. One also fundamental component is the way you build the network graph. So the auto-peering mechanism is also very fundamental, but it's somehow complementary to the other two.
Right.
And apart from this, you have another transversal component, which is the civil protection mechanism. This is what makes the huge difference. So going to something like Bitcoin, so in proof of work, will not provide the characteristic that IOTA is looking for. So we couldn't use, so the first requirement we had when we try, we had a white paper in the sense of white, and not in the sense of, of the white paper. And
white paper.
Yeah, white paper, empty white paper, and try to put some ideas, right? So Sergey used to say we cannot have a leader-based consensus protocol, because this will not scale. So we started from this, basically. This was the only thing we had, and then we start to think what are the options. So
maybe sorry, Luigi. Maybe can you quickly explain what the leader-based consensus protocol is?
Oh, sure. So if in Bitcoin, for instance, you have this proof of work. So you have the various node miners that tries to solve a cryptographic puzzle. So there is a sort of race. Who wins this race? Who solves the cryptographic puzzle first? Then has the right to write into the ledger.
Yeah.
Right? So having the right to write into the ledger also give some reward. That's why there is this competition. All the nodes want to solve the puzzle first because they want to write into the ledger. And Bitcoin solved that by having this puzzle called the proof of work. But as you can think, this is something sequential. So you have a total ordering of stuff. So you need to give the right to one person, to one miner, and then one after the other, then you have this transaction, this block of transaction that will be appending in the chain.
Right.
We didn't want to do that. We want to do something more dynamic, as something that might enable actual scalability. Bitcoin has a huge problem in terms of scalability. We're talking about a few transactions per second. And obviously there are options, and people are trying to study how to make it scalable, but it is both the civil protection mechanism they use and the ledger structure, the total ordering does not really allow this scalability in a natural way. So we started from there.
Yep.
IOTA is fearless and IOTA want to be scalable. So according to this, we try to think differently, and we came up with this mana approach. This big topic of mana that
exciting mana.
Yes. It is very important to have mana. Yeah. Maybe right now we get a question, but why this is still centralized? You need 30%, 50%, whatever. This is not the only reason why, because it's different. Obviously, if you have one node that has all the mana, this will not. It will work in a similar way as the others, and you will, elect one. But you have to think in a way that this will enable a more complex and flexible way to look at the network. So the biggest problem in other, in this crypto space and in other cryptocurrency is the fact that the power is somehow centralized. So you have a few nodes that are, can somehow they have the power to write. They decide what is the consensus, and this will naturally happen if you leave the network alone. With the mana, we want to have just one metric to build a more complex reputation system. So this will be in the future. It is currently under research, under study. We want to have a flexible way to reward also small nodes, IOTA for Internet of Things, to somehow reduce the distribution of, normally this will follow so-called power law distribution, where you have just a few nodes with the large power. In this way, we can have some countermeasure to also favor the good behavior of nodes or penalize the bad behavior. So this system gives us this flexibility.
Right, but let me try and summarize it. Right, so let's think about Bitcoin today. Bitcoin and also Ethereum and other delegated proof of stake, right? Proof of stake in general, they're leader based. That means that in certain intervals, through some mechanism, either proof of work or proof of stake, a leader is being elected, and this leader is a specific miner or validator that basically creates a new block, publishes it to the network, and then it reaches consensus, right? It gets the security of the more blocks get appended. That is how blockchain works today, roughly. And that is how nearly all of the protocols ahead of us work on CoinMarketCap. Now, what we are doing with IOTA is, because we are no longer based on a blockchain, but on this directed acyclic graph, we no longer want to elect a leader, because electing a leader, like you said, or like also Sergey said, is a limit, because the election is a limit, and this leader can only do so much. And as such, we want to parallelize the transactions that can happen and the transactions that can be confirmed. And that is what makes IOTA so unique. We no longer have this serialized consensus, but it's really parallelized. Transactions happen at the same time from thousands of IoT devices, thousands of people, right? We also for humans. and the beauty of the Tangle is, because it is parallelized, it is able to scale. And one of the most important properties of IOTA was feeless transactions. And this is where the difficulty arises, right? And this is why we had to invest so much time into this, because one of the most difficult parts of a blockchain are the Sybil protection mechanism. How do we ensure that somebody doesn't spam infinite transactions? Because if they can do that, they can double spend, right? They can attack the network. And this is exactly where mana and the rate control mechanism come into place, because they basically protect the network from those attacks. And maybe let's talk about the requirements actually, and why mana is needed, or why the congestion control mechanism is also needed. Because I think these principles also really help me to understand the kind of properties that we're looking at, right? Because when it comes to researching a distributed ledger and working on it, there's always some kind of variables and some parameters that you can optimize for certain use cases or for certain requirements. And you get a very different architecture out of it. Like, for example, what Solana is doing is they can do tens of thousands of transactions per second, but they have a very different focus and a very different use case of IOTA. And that's why you only really highly spec'd out hardware and nodes can join their network, where you need to have gigabit connections, network connections. With IOTA, the focus is differently. So let's maybe go through the requirements.
Yes, as you said, we are doing things. We have specific requirements, and in this 2 years and a half, many times it happened that Bitcoin, they use fee for that. Oh yeah, it would fee. This will be easy,
Yeah.
So the infrastructure, the networking layer, or the kind of networking attacks that we might have in the network it will be almost trivial to be mitigated by just adding fees or adding some other filters.
Yeah.
This does not happen with IOTA, because we definitely don't want to impose any sort of fees.
Yeah.
So what are the requirements? As I said before, we can reuse some of the information that we have in the standard networking, where I want to send a transaction from a point A to point B. So these standard requirements that are pretty well known in the literature are, for instance, get fairness.
Yeah.
When you share your network accesses, depending on some reputation, you can see that when we talk, for instance, about service level agreement in telco.
Right.
That's a very immediate example of fairness. Efficiency. So we have resources. The resources are limited. You have the CPU, the bandwidth, the storage, the buffer capacity of the nodes, and we want to use them and have them optimized. You don't want to have unused resources.
Right.
It will be easy to just, to guarantee fairness, to just say, well, I get 1% of the money, of the reputation, and I can issue 1% of transaction. This will be trivial to do. But in the case then maybe there is unused bandwidth because there are nodes that are not sending transactions at that time, the network will be unused, underutilized. So this is the, efficiency makes things not that trivial. But the actual thing that makes the problem challenging is the consistency. This is a thing that we don't really have in the standard network. Because in DLTs, what we want to do, we have a message, and we want to deliver this message to all the nodes that participating in the network. Yeah. And it is not the same complexity of consensus, but almost, because to get consensus, you need to give the possibility to all nodes to understand what are the transactions in the network. And if the transactions are not successfully delivered to almost all nodes, when I say almost, it means basically practically all of the nodes, it is not possible to get to a consensus, because I cannot, for instance, participate in our voting mechanism if I don't know if a transaction exists. Or maybe I can start building on top of transaction that other part of the network cannot see. So the consistency requirement, what makes things differently than the standard networking and makes things challenging. And on top of this, obviously, we require security. So we don't want an attacker can affect any of fairness, consistency, or efficiency requirements.
So these are the four main requirements that we went out with when solving this network challenge, right? And just to quickly go through your presentation here, right? We have, like, when it comes to IOTA 2.0 core design, we need to look at the consensus. The consensus is done by FPC right now, right? Fast probabilistic consensus. The network is exactly what we are discussing right now. And this is where the rate control component, and this is where mana also plays in. But for you, mana also, like mana sits more in the civil protection here, right? And it actually feeds into all of these three components, actually, right? It's also part of the consensus, it's part of the networking, it's part of the auto peering. And so it's really like one of the core components of Corticide.
Yeah, that's why, when we started we thought, what is the civil protection mechanism we want to build? What is the way we want to guarantee access and the guarantee that the transaction are, the nodes agree on which transaction. So we started basically according to this, and then we build the infrastructure around that. Right. So once we chose mana, then we said, okay, now we have a way, we use just as an input parameter for networking. So you say, what is the mana I have? Well, I have those mana, I have this percentage of bandwidth. And then the protocol, the networking protocol will work by itself if we don't have mana. For instance, you can work with the same reputation for everybody. This is an external component that feeds the networking layer, feeds the consensus, because as well in the consensus, you want to weight the power of the nodes on deciding on agreeing on the transaction, depending on the weight. And same thing on auto peering to prevent some trivial attacks, for instance, eclipsing part of the network. We also use the mana there.
Right. But so let's maybe dive into mana, because mana is part of this broader reputation system that we have in Corticide. And as we wrote in this blog post here, civil protection, right, where somebody cannot create infinite identities and attack the network, is a very important security mechanism of any DLT. The way that every other network out there solves it today is through proof of work or proof of stake. Now, what we in IOTA utilize is mana. And as we wrote here, it's part of all the components of Corticide. So can you maybe give me a high-level summary of what mana actually is and how it works, because there's two different manas that we have to consider, right? So let's maybe start with the high-level, simple explanation of what mana is.
Yes. So we need a way to understand who can have this access and who can decide on transaction.
Yeah.
But in order to prevent some attack or creating multiple identities, we need to verify the access to a scarce resource.
Yeah.
So Bitcoin, this is solved by saying, okay, the scarce resource is the CPU, the hashing power. Other approach, proof of stake based, depends on the stake that they have, on the tokens that they have staked.
Yeah.
We have an approach that we want to reward nodes depending on the work they are doing. Normally, when a transaction is issued, so we can decide what we call the node at which we will pledge the mana. So each transaction will carry some mana which are proportional to the amount of tokens that are shared.
Yeah.
And the issuer of the transaction can decide to which node you will be pledging. The most straightforward strategy just to reward the node that is doing the work, because it is generating the transaction, signing, doing the proof of work, and issuing, gossiping, etc. But we have the possibility to reward whoever node we want. So this is important, and we cannot avoid to do that because otherwise, think of an attacker might create just infinite identities and participate in a voting mechanism with the infinite amount of power just for free if we wouldn't have this civil protection mechanism. Yeah. And the same thing for the networking layer. I could create, spin up nodes just for free and send transaction at basically infinite rate without any control if there's no a way to have a resource and split the resource like it was a cake, split this cake and give a little bit of a little piece of cake to each of the participants.
Have your cake and eat it too, right? But this is like, I think Mana, and this is why I get so excited about what you said initially. Mana draws this perfect comparison to the spectrum. Because what we have with the spectrum today is we also have this scarce resource, which is the frequencies, right? We need to figure out how we actually distribute access to which frequency of the spectrum, right? There's TV, there's radio, 4G, 5G, secret frequencies for the military and all of that, right? And we need to think about how we actually distribute this resource. And the winners of the Nobel Prize in Economics this year actually solved this problem in the telco market. And how they solved it is through auctions. Maybe I can actually Google this.
Yeah, that's interesting. I didn't know about that.
Yeah, so spectrum auctions. And what they are doing, right? So you have somebody that wants to utilize the scarce resource, and the same way that you defined it before, right? We have these important properties that we need to take into account when we design these protocols, which are fairness, consistency, efficiency, and security. And the same is true to these spectrum auctions. And this is where it also clicked to me that what we are doing is we are applying similar principles from past protocols, like everything that has to do with telco, and adapting them to this new decentralized world. And that's so damn exciting what we're doing, because if you think about Mana, it's also sort of auction mechanism, right? And the way that it works is that you hold IOTA tokens, and with your IOTA tokens, you're already a participant in the auction, right? You're already a participant in the network because you're able to generate Mana. And this Mana is then sort of the rate control, which really helps to determine how the scarce resource, which is the transaction throughput, should be distributed, right? Who should get access according to the fairness, according to the efficiency, security requirements. And that's what's so amazing about it, right? And it's a very simple concept. But as we wrote in our congestion control blog post here, this is really the first time that we actually have a complete new congestion control mechanism, right? Mana is part of that, and that hasn't been done before by any other DLT. And for me, Mana is really one of the most exciting concepts about Corticide, because it just really proves to me that IOTA is evolving out of just being a cryptocurrency towards something that is becoming a real piece of technology, right? And I think it's so damn exciting.
Yeah, and the flexibility that gives us Mana, it's amazing, because we can, for instance, I'm participating in the network, but I don't know, I have my Mana there, I'm not using, I can even, for instance, rent or give pledge to somebody else for some time.
Yeah.
There are basically infinite possibility. And that's really the key point that makes things extremely different. And probably one thing that we haven't mentioned yet is the distinction between the Mana for the access and the Mana for the consensus. That's also a key thing. While access Mana, for instance, I could trade, I could send, I could share, I could rent, whatever. It is something dynamic. It depends on the access to the channel. If I don't have to access the channel at some point, I can, my Mana can be used by somebody else. I can apply to somebody else, so I can rent. But for consensus Mana, obviously, we need to be more strict, and there is no way that this can be tradable. So this is the main difference between the access and consensus. One will be used only to write transaction to the ledger, generate transaction, and issue them, while the consensus will be what is inside FPC. So what is used to decide which transactions are legit or which transactions should be discarded. That's really.
So is it valid to say that we have two manas, right? Access mana and consensus mana. Consensus mana is there for purely FPC, right? It feeds into the consensus. That means that I hold IOTA tokens, I generate access and consensus mana. And when I issue a transaction, my consensus mana is being utilized, right? That's how I can understand it as part of the FPC module.
Yes, in order the weight of the votes in FPC depends on the consensus.
So it influences your weight. Yeah, got it. And access mana is part of the auto peering. That means that if I want to be Sybil, if I want to be protected against Eclipse attacks, against other things, I need to have mana in order to access the network, right, with the auto peering module. And also the networking and the other components, this is where access mana plays a component, right? You said when it comes to storing transactions and all of that.
Yes. The exact parameters we will be testing on the Goshimer testnet, For instance, sometimes we have thought, okay, we might have a combination of the two. Maybe you will give, 80% of weight to consensus mana plus the 20% of the access mana, and you do a hybrid metric. I don't know if this is something that we finally will do, but it is under testing, and since now we have also mana implemented in the Goshimer Poland test network, we can play a little bit. But the overall idea is just the high level idea is just to use a consensus mana for FPC and the access mana for the other component.
Yeah. And I mean, that's really why mana is such a major milestone for Goshimer, because so far I remember we had like very different variations of mana with different decay functions and all of that. And it's interesting to look at it, but I think what will be even more exciting is just to test it out in the real world, right? And run real simulations. So I think also for you, right? Now with Goshimer, we can do real life networks, real life deployments of mana. So it's a major success as well, right? So we have to appreciate that.
Yes. Building a simulator is good because you can test whatever you want,
right.
But both you have to make assumption, and then you also don't have the real actual data that in network makes a difference. If my server is located here and the other server is located in Europe or in Asia or in US, obviously the fluctuation in the connectivity on the node performance capability, it is what makes a difference. I can simulate, with the Python, Go, whatever, but once you have the real deployment, this is a huge improvement, and obviously we're gonna do heavily testing all
and I think this is also very exciting for all of you who are watching us right now. Like everybody will be able to experience mana over the next 4 to 8 weeks. Right? We are launching the Nectar network where all of the different components of Cortisite are integrated, where mana is being utilized, where access mana, consensus mana is being utilized by all of the different modules of Cortisite. And then all of you will be able to test it out in real time. We already saw some community members actually setting up nodes and generating mana. And I think this will be so much more exciting for all of you, because now with Nectar, Cortisite becomes so much more tangible to everybody, because so far it was amazing to watch the research, to read the white papers, look at the math and not understand it. But it was really great from a theoretical standpoint, right? Because it was peer reviewed, but now it gets put into practice. So that's really, really damn exciting to see. So
we had several ways to compute mana, various proposals. It is the core component. So I think it is normal that we tried out different things. And I understand that it was not always 100% clear. But now we have the concrete proposal with testing, and everybody can actually see how that works.
Yeah, no, that's really exciting. So in relation to that, let's maybe talk about the rate control or the congestion control mechanism, because that is also an important point of Corticide. Because as we saw with Nano and as we saw with some attacks on IOTA, feelers is damn difficult. And mana and our rate control mechanism are a solution. So can you maybe explain a little bit about what rate control is compared to mana and what it actually enables?
Sure.
And is this a right picture, or should I show
Yes,
this?
no, that's perfect. This picture is perfect because high level enough to give a general overview.
Yeah.
So yes, we actually saw that in other networks this is an important problem and a problem that actually exists. And as you pointed out, there is not much literature in the DLT space about this problem. Mostly because the solution is that, well, we don't have congestion right now. We will think about that once we get to the problem,
Yeah.
But since we're trying to do things, pragmatically and starting from scratch and building the entire system, I think we took a different approach and tried to build things how they should be built, thinking of a production-ready IOTA protocol.
Right.
So let's try to describe this picture. In the middle, you have the node and you have the neighbors. So this node is connected to I think that it is. We have 8 neighbors now for each node. So what we want to do here is to decide what transaction should be forwarded to the other nodes. And in order to guarantee all the properties that we have listed before in terms of efficiency, consistency, etc. So to do this, we use 2 modules which are proper of the networking background. One is a scheduling algorithm and one is a rate setting. So the scheduling algorithm simply decides which transaction will be the next one to be scheduled. When I say schedule, it means which transaction will be chosen to be forwarded, gossip to the neighbors, and to be written in the ledger. The way the scheduler works is not complicated. We have several queues depending on the node ID that issued the transaction, and we iterate over all the queues depending on the mana of each node ID. So obviously, if a node has a higher mana, then we stick more time on a certain queue. While if a node has less mana, then we will jump rapidly to another node ID. This is weighted depending on the mana. So mana comes into the play exactly here in the scheduler when we decide which transaction must be forwarded and passed to the Tango.
So that also means that if you have more mana, your transactions will propagate in the network better because your transactions will be more prioritized. Is that right?
So here, there is a caveat here. So we guarantee that approximately the delay for a transaction to go through the network is the same for all transactions if nodes are honest. So the delay only increases for malicious transaction. Why we want to have this property and why we don't want to have a faster transaction or slower transaction? This is because actually in the way our consensus protocol works. So this consensus protocol doesn't work with the average delay. So, but with the maximum delay. So we want that the maximum delay at which a transaction are delivered to all nodes to be capped. So it is not important if, for instance, 99% of transactions are delivered in 1 second and 1% is delivered in 20 seconds. It is better if 100% of transactions are delivered in 5 seconds. And why this? Because of the way our finality works and the FPC works, we have this FCOB rule. REFCO rule says that we have to wait up to 5-10 seconds up to this time in order to confirm having what we call the first degree of finality. So to be for a transaction to be confirmed. So even if the transaction is delivered in 1 second, in any case, we have to wait up to the FCOB rule, so up to this 10 seconds. But if we allow transaction to be delivered, as in the first example, where there is 1% of transactions that are delivered in 20 seconds, then we would have to wait for 20 seconds. While in the second scenario, where 100% of transactions are delivered in 5 seconds, it's true that the transaction is not delivered faster, but this doesn't matter because we can just wait 5 seconds. Right. So this is, a little bit tricky, but it is how the way we designed the system to minimize the maximum delay.
Yeah, no, but I really loved it, and that's a very important property, right? Because the way that I always saw that Tangle is really as a sort of egalitarian protocol, where everybody has the same sort of rights in the network, right? I can deploy a node and I can issue a transaction and I can confirm 2 transactions in the history. I don't depend on a miner to include my transaction. I don't depend on the fee market to not be overflown right now. I don't depend on miners to include my transaction in the next block, but I can participate. And I really love this property that we try to optimize to minimize the maximum. Right, maximum delay to propagate the transaction, so that everybody gets the 5-second confirmation times.
Yes, this was one of the main principles, to try to understand how we can make things for everybody. So we always have this heterogeneous network, heterogeneity in mind, and try to build according to that. We know that will be faster devices, slower devices, and we try to make a system that can work for everybody. Right. And this is another challenge, actually.
No, it's a big challenge, right? Because you have something like delegated proof of stake, where you have those validators, those nominators that are the main consensus makers and the main nodes in the network. And then you have concept of master nodes in some other networks. And I'm really not a big fan of those, because we are thinking about the Internet of Things. We're thinking about everybody being able to set up a node in their router, right, and being able to just participate in the network, and that's really why it's beautiful. So, right, we were stuck at the scheduler. Could this be compared to the mempool of Bitcoin or Ethereum?
Yes, it is. Since the concept is pretty different in the sense that both create a filter, create a barrier. But in one case, you're basically giving priority to the strong ones, and here we are just trying to do something in terms of fairness and try to be, optimize some certain properties. So I would say the mempool might be a very raw version of the congestion control algorithm. It is a congestion control algorithm in the sense that it creates a filter, so it receives a lot of transactions, then spit out a few ones, but it doesn't ensure any of the properties, it doesn't ensure most of the properties that we are discussing right now. It makes IOTA unique. So it is much more elaborated. So it is a component we all in the team are very proud, because we have done a heavy research on this. And I have to give credits as well to Bob Shorten's team at Imperial College. We're collaborating with them, and we make a really big progress in the last year, where we really designed and implemented and simulated all possible attack vectors and fairness properties, whatever.
Right. And just for all of you, Bob Shorten is on the research council as well. And he's a great research partner. And we work with Imperial, and they're also really world-leading experts on congestion control algorithms, right? So they really gave a lot of input here as well. So it was great to design this together with such an established university as well. So a lot of work
yes,
went into this.
definitely.
Yeah.
That's
So
amazing.
if I were to describe this, the blacklister, so the blacklist is basically there for transactions
All
from an
right.
attacker. Yeah, maybe
All
you
right.
continue.
So there is, I just go rapidly to the rate setter, and then we can talk about the blacklister. So, alone the scheduler doesn't guarantee that we can have protection against attacker. Because, for instance, I'm an attacker, I generate transaction at a higher rate that I am allowed to. So the scheduler can decide which transaction, but at some point the buffer might be filled up because an attacker is spamming a lot of transactions.
Yeah.
So in principle, the rate setter is what guarantees that everybody, the honest nodes, they know what is the rate at which they have to issue transactions. This works similar to TCP, where we have an additive increase and multiplicative decrease. So just to give an idea, I started with a certain rate, which I think it is what I should do depending on my reputation. Then I increase up to the point that I see congestion. When I see congestion, then I drop it. I drop the rate. So when I see congestion, we use the inbox queue length. So if I see that the inbox are growing, it means that I'm probably going too fast and I have to slow down. So if I'm honest, I will follow this rule and I will not congest the network. But if I'm malicious, I can I don't care about the rate setter and I can issue transaction whatever rate I want. And the blacklister basically look at the queues in the box queues, and since we know more or less what will be the inbox queue length on average, if I see that there is some outlier where an inbox queue is getting too large, then I can decide to drop the transaction from this particular node and potentially blacklist and avoid, drop the connection with this neighbor or whatever action that limit the possibility for the attacker to affect consistency.
Yeah, I'm trying to find the image right now because this was always one of my most favorite images of Corticide, but it's not this. Where you have the bee shimmer, and that's why I love the term shimmer, because like when I think about, okay, that's not what I want to show.
Sounds looks like not actually.
No, because what I'm trying to show here is actually, when bees have like this mechanism, this self-protection mechanism, like they have here, right? The way that I think about our Corticide always is, the way that we are trying to think about this is that the network itself has a self-healing process. That means the network should early on detect if there's an attacker and should protect it, right? And so the rate control mechanism is part of that because it makes sure that an attacker is not able to flood the network with their malicious transactions, right? So yes. I really love that principle.
And the different thing. So we said before that we do things we take the principle from network and we apply here. And I said we use scheduler, rate setting. But the way TCP works, when we send packets, so we get feedback from the neighbor, feedback from the other nodes. But in to guarantee security in DLT, this is not the safest thing to do. So all this component here works locally. This is actually the beauty of the algorithm. So we don't ask information to neighbor and rely on something which is external. We only rely on the local information we have. So for instance, the inbox length, the information about mana, etc. That is the thing that actually makes the difference.
No, exactly right. It's like every node is contributing to the security of the network. And it's not just master nodes, it's not just the miners, it's not just the coordinator, right? It's everybody's making it secure. And that's why I find it so beautiful. We need to hire more bee marketers to showcase the the beauty of it.
I remember there was a nice graphic GIF about the cellular automata as well, how to propagate this to the network was amazing.
I know. I'm trying to find it right now, and I couldn't. I thought it was on the website. No, the cellular consensus.
Maybe on the consensus.
You mean this one? Yeah, exactly. This one. It was this one.
Yeah, one of the early research on cellular automata.
Yeah. We're actually going to publish an update on that soon, right? And what's up with cellular automata. No, but I think all of it makes a ton of sense. And maybe something about mana. All of you, if you have more questions about mana, we can't answer them all on the show tonight, but make sure to go on Reddit, because on Reddit we have the Q&A thread, and make sure to ask all of your questions about mana there so that we can further explain it. And don't worry, right? We're just at the start of the mana journey, because it was just integrated into Go Shimmer. And over the next few weeks and months, we're going to do so much more explaining, and also so much more tools and applications that you guys can download to try out mana yourself. So I think that all of that is super exciting, because it's all coming to life right now. So that's really exciting. And maybe one last question that I want to ask about zero mana messages, right? I think this is a very important topic, because we think about the permissionless network where anybody should be able to spin up a node and participate. And at the same time, we're talking about the decentralized network where people have to contribute some kind of resource like IOTA tokens to generate mana, and in order to secure the network and to be able to participate in it. Can you tell me a little bit more about what the goal is with doing zero mana messages? Or not the goal, right? What is the current path to enable it from your point of view?
Yes. So this was a hot topic in the last few months, actually, and it is challenging, because we said that the civil protection mechanism is mana. Yeah. Now we are pushing this even further, and we're saying, but we want to enable without mana, so without civil protection, to be able to issue transactions. So this push, the challenging much more than just using civil protection and having a congestion control mechanism, an access control mechanism. So what is the status here? There are actually various options in order to issue transaction if a node has no mana. For instance, one of the idea which we are thinking of is to create a faucet where we can voluntarily ask for mana, and then we receive some mana. Obviously, this will be limited, but this might be just for testing the network, and and basically voluntarily, so the faucet can provide mana where you want. One can rent mana, can buy tokens and get mana. One of the requests we had is, but we don't want to do that, and maybe a node cannot, or we want something faster, or look, if the network is not congested, I want to issue transaction. All right, perfect. That's this true. In principle, network is not congested. We can give the opportunity to issue transaction. However, if the network is not congested and we relax too much this constraint of the mana, then the network might be congested basically in no time. And then this might affect what we were talking before about the consistency criteria. So my take is that we need to pay attention. So we have sketched a proposal where you have a minimum threshold to issue mana, and then this threshold can be adaptive depending on the current congestion level of the network. Mm-hmm. So this is a feature that we can add to the baseline congestion control protocol, but obviously we must be 100% sure that we don't introduce any attack vectors, any vulnerability. So the first step will be we test the current congestion control algorithm in the Gaussian network, and then if things goes really well, we can add and test this feature. But as I said, I don't expect that. All right, we just add and I suspect it will be something to test, to modify the parameters, to maybe rethink as well. And maybe at the end we can even add to the main protocol. But I'm just saying it's not straightforward, so it requires some research.
Totally, and I mean, like, the further you dive into it, right, the more you think through, hey, like, this has this trade-off, and as you said, ultimately it is about providing a protocol that will be utilized, that is going to be adopted by the real world. So the way that I see it, right, we are on a journey to be production ready, and right now we have Gaussian that is moving towards Nectar. Nectar is this incentivized testnet. And there already, it will be really exciting to see how Corticide, how all of these years of research is now coming together in this new protocol, and also getting the community to finally participate and try it out. And we're just getting started, right? We have so much more to optimize. And you were talking about in the beginning the marginal optimizations that can be done on the existing internet infrastructure, right? We are talking about decades of research that was spent there, and billions of dollars, and people all around the world. And with IOTA, we are just at the start of it, right? We work together with like nearly a dozen universities right now. There's so many more research papers and patents that get registered on IOTA. But with Corticide, we are at the start of this new consensus protocol, and it is a leaderless consensus protocol, and is going to be fully decentralized and secure. And then after that, we can always optimize further, and then we have data sharding and all of that. So, and sharding in general. So it's very exciting.
Yes, exactly. That's just the baseline, and then there are many other things we can do. I mean, only talking about networking, we said this feature, the zero mana messages, but I can also think of the optimizing the gossip layer, the solidification request, to improve the performance, to improve the transaction per second, the data sharding. This will be disruptive, and a very important change, and to improve throughput and scalability. So there are like limitless direction and research direction, implementation, optimization we will do, and we have already started to work on, actually.
Yeah. No, this is super exciting, right? And we have so many more things to also publish in terms of our research, and it's very exciting. So yeah, I think that made MAN and the congestion control algorithm very clear. Do you have any other closing statements or things that you want to mention about this? About Corticide?
I think we touched most of the points. About congestion control, we could talk for hours, and about MAN as well. So I think we spent like more than 1 hour, 10 minutes, and
it flew by so quickly.
5 minutes ago.
I actually missed the call.
There will
maybe
many things.
Because I know you just presented your work at the University of Amsterdam, Technical University.
Yes.
Do you think we can publish this presentation?
I think so.
Because this would be really interesting for all of you who are really more into the hardcore technical stuff. I think this presentation is really beautiful because it explains MAN and the congestion control algorithm a lot further.
Yeah, there are also some references to some of the our works, so it will also be some. Yeah, definitely. Let me maybe go through it after the talk. But I think it should be fine.
Yeah. No, but that sounds great, Luigi. So for all of you who have more questions, make sure to either ask on Reddit, right? We're doing the AMA next week, and maybe we can just make it about MAN, depending on how many questions we got. So maybe you can join again. Other than that, if you want to directly interact with our our researchers go on Tangle Math on Discord. We are always open to questions there, and I think it's always interesting to debate and challenge our thinking. And yeah, so thanks a lot, Luigi, for joining today. Any closing statements?
No, I mean, I think everybody were so excited about the next, upcoming release and upgrades of IOTA that I can't really wait.
Yeah, it will be so exciting to see it in real life, and like it's 4-6 weeks away, right, with Nectar, and so it will be super exciting to try this out ourselves and to also see what the community will build on top of what we're building. Because as you said in the beginning, we are doing this to build the protocol for the real world. And we're really, really on a good journey for that. So yeah, thank you everybody for joining today. We're going to do a lot more research discussions and like fireside chats and educational material. Thanks a lot, Luigi, for joining. And without further ado, have a good weekend and see you next week. Bye-bye.
Thank you, Dom. Bye.
Thank you. Bye-bye.